Hello, dear students. Good evening, everyone. Hello, Lily. How are you? Good evening, guys. Hello, everyone. Can you able to see me? Video and audio clear, guys? So, is it live? Just confirm. Just message everyone. Hello, Ghosh. Anupama. Hello. Tushar. Hello, Tushar. Happy Diwali. Yeah, crackers nailaya. Hello, guys. Hello, hello. Good evening. Good evening. Pardev, good evening. Okay, right. So, guys, welcome all. Welcome to Unacademy Accelerate platform. So, let me introduce myself. Myself, Praneet Kalyanam. I'm maths educator at Unacademy. I have 10 years experience in teaching IIT-JEE maths. Previously, I have worked in Narayana Chena campus, and before that, I have worked in Akash, Bangalore. I'm from IIT Roorkee. Welcome, everyone. So, guys, hello, Nikhil. Hello. Happy Diwali, everyone. So, how are you all? So, guys, this is my referral code Praneet10, and these are the packages we have to join Plus platform. So to take Plus subscription for 6 months it is 28,000, and for 2 years it is 56,000, and 1 year it is 38,500. And if you use this referral code, you get instant 10% discount. Okay, Pardev. Very good. Very good. Excellent. Excellent. So, guys, so there is a special announcement today. So from 20th November on Unacademy Plus platform, micro class 11th is going to start by the top educators, guys, for JEE mains and advanced 2022 for 11th class students. And this batch is going to start from 20th November, and India's top educators are collaborating. These all faculties are from Vibrant Academy, guys. Vikas Gupta sir, MS Chauhan sir, Nitin Jain sir, and Neel Kamal sir, Narendra Avasthi sir, Pankaj Joshi sir, Vimal sir. So all these top educators are from Kota, and these faculties are very experienced, and they are from a Vibrant Academy. Unacademy is tying up with Vibrant Academy, and this micro class 11th is going to start from 20th November, guys. So you will get maximum benefit with this micro class 11th. So for 2022. So if you want to join this course, you can take this referral code Praneet10, and you will get instant 10% discount. I showed you the packages also. You can join this Plus platform. Okay, right. So this is for class 11th, guys. So this course is going to start from 20th November. For class 12th, we'll start. After this, we'll start, guys, for class 12th. Okay, so this is for class 11th. Already for class 12th, we have started few batches. So this is for class 11th. Okay. So, hello, Polo Paul. How are you? Class 12th batch is already started, guys. Okay. So everyone join this batch. So if you are in 11th and if you want to join a good batch where you can get the maximum benefit, you can take this course and join, guys. So if you are in Plus, you can follow. If you are not in Plus, you can take this referral code and you can join Plus platform, guys. Okay. Chalo. Let's start the class then. So, guys, in this class, we are starting permutations and combinations. So in the first class, we'll discuss the 2020 September mains questions. And in the next class, we'll discuss 2020 January questions, and 2019 questions we'll discuss. Okay. So everyone start, guys. Start doing this question. If the letters of the word mother be permuted in all possible ways, all the words are listed in a dictionary mode, then the position of the word, rank of word he is asking, guys. Rank of the word mother, sorry, here. This is a mother, rank of the word mother is how much? That's what he's asking. So this is very simple question. Rank of a word mother we need to calculate. So we just need to arrange all the letters of the word in increasing order. Dictionary order, alphabetical order, and then we can calculate the rank of the word mother. So everyone start doing this question. So do it, fatafat, do it, guys. I'll give you 1 minute time to do this question. First, let's arrange these words in alphabetical order. So this series for this 3000 problem solving series is for entire maths, guys. So already we started algebra. In algebra we completed 2 chapters. Sequence and series we complete. Binomial theorem we completed, and then we completed complex numbers. 720. No. See, total number of words we are getting is 6 factorial, which is 720, guys. 720 words we are getting it. Out of this 720 words, mother is which word? That's what he's asking. If you arrange all these 620 words, mother will be somewhere. So what is that word mother? He's asking. Okay, right. Let's arrange these letters. So total 6 letters are there. All these letters you arrange it in alphabetical order. Right. So these 6 letters are arranged in alphabetical order. So what is the answer, guys? Anyone? Anyone got the answer? Jasper Jolly is saying 309. Okay. Anyone else? Anyone else, guys? So I'll tell you the concept, guys, how to calculate the rank of a word. So required word is mother. Required word is mother. So for that, what we need to do is we need to calculate number of words starting with E. Why? Because to get M, first we need to calculate number of words starting with E and H. So number of words starting with E. How many will get it, guys? Isn't it 5 factorial? Isn't it 120? Correct. Same way, number of words starting with the H. How many number of words starting with the H, guys? So total 5 places are there and 5 letters are there. Again 5 factorial, 120. Same way, number of words starting with M also 120. But in that 120, our required word is also there. So now what we need to do is we need to calculate number of words starting with ME. Number of words starting with ME is 4 factorial, which is 120. Next, number of words. Okay, let me do it this way. I think here you are not able to see this. ME here. Now tell me, guys, MH, number of words starting with MH, guys. How many are there? 4 factorial again. So this is 24. 4 factorial again 24. And after MH, MO, number of words starting with MO also 24. Okay, 309. Okay, 307, 409. Okay, let's see it, guys. So here also 4 factorial, but required word is also consisting MO. So one more letter we should add it from left to right. MOE. So MOE means what? M is over, O is over, MOE. So again 3 factorial, which is 6. Next, MOE. After MOE, MOH will get it. So remaining 3 letters can be filled in 3 factorial way, 6, which is 6 ways. Next, MOR. MOR also 3 factorial ways, which is 6. Next, after MOR, we get MOT. But our required word is also MOT, guys. So now one more letter we should take it. MOTE. So 2 factorial, which is 2. Clear na? Right. Next, after MOTE, MOTH. But our required word is also MOTH. So one more letter from left to right we should add it. So which is MOTHC. But our required word is also MOTHC. So one more letter will add it. So total 0 factorial, which is equals to 1. We need to add all this, guys. Let's add all this. If you add all this, 120 plus 120 plus 24 plus 24, 6. All this if you add it, how much we get it, guys? 120 plus 120, 240. 240 plus 48 plus 6 plus 6 plus 6, 18. 18 plus 2 plus 1, which is 21. So if you add all this, how much we get it? 309 we are getting, guys. So answer is 309. So this is one method. So guys, this is one method. Everyone got 309. Otherwise, we can use this shortcut method here. So here shortcut method is we need to calculate letter M. So before M, how many letters are there? Before M, so 2 letters are there. So 2 into 5 factorial. Next, before O, again 2 letters, so 2 into 4 factorial. So if we use this formula, we get the answer easily. So this way we can get the answer easily. So to apply this case, we should not have any letters repeated, guys. If a repetition is there, then this shortcut, we can't use this shortcut, guys. Clear now? So otherwise what you can do is better if you learn this method. If you learn this method, then it will be easy. Clear? Right. Chalo, let's move to the next question. This is the next question we have. Second question we have, n is greater than 2 is an integer. Suppose that there are n metro stations in a city located along a circular path. Each pair of stations is connected by a straight track only. Further, each pair of near stations is connected by blue line. So let's take n dots are there. So let's take n dots, guys. N dots are represented by n metro stations. So like this you can take it. So total n dots are there. Something like this. We don't know how many dots are there. So we need to calculate that dots. And what he is saying is, each pair of stations is connected by a straight track. Further, each pair of nearest station is connected by blue line. So let's take a blue color line. So this is connected with the blue color. Each and every nearest station is connected with the blue color line like this. Like this we can connect it. Clear? And then remaining all pairs are connected by the red color line. So red color line means we can connect it like this. Let's take a red color line. So we can connect it like this, and we can connect it like this. All this we can connect it. So there are so many possibilities are there. So you can connect all this. We can connect it like this. All this we can connect it. So what he is asking is, if number of the red lines is equals to 99 more number of blue color line. That's what he is asking. Okay. Right. So tell me, guys, let's say if there are n dots are there, let's say 1, 2, 3, 4, 5, so on up to, let's say, n dots are there. So in that case, number of blue color lines are going to be n only, guys. This is a 99 plus n only. So red color dots we need to calculate. Red color dots are nothing but number of diagonals of this polygon only. Number of diagonals, what is the formula, guys? Number of diagonals in polygon is going to be n into n minus 3 by 2. N into n minus 3 by 2. This is the number of diagonals formula. Number of diagonals in a polygon is n into n minus 3 by 2. So if you substitute this value here, n into n minus 3 by 2, and cross multiply and simplify this, let's see what we get it. N into n minus 3 is equals to 198 plus 2n. So now if you simplify this, n square minus 3n minus 2n, n square minus 5n is equals to 198. This is what we're getting, guys. So which is n into n minus 5 is equals to 198. Now you can able to calculate the value of n. Correct now? If the number of red lines is 99 times number of blue color lines, okay, 99 times guys, so into here, this is into here. One second. Here multiplication guys, this is multiplication. So now let's solve this. So n get cancelled, and finally we get n minus 3 is equals to 198 we are getting, and n is equals to 198 plus 3, 201 we are getting it. So 201 is the correct answer. Correct now? So guys, is it clear? If the number of red lines is 99 times the number of blue color lines, number of red color lines is 99 times number of blue color lines. So blue color lines is n only, number of red color lines is equals to n into n minus 3 by 2. So when we cross multiply this, n minus 3 is equals to 198 and n is equals to 201. Is it clear guys? Everyone understood this? Got it? Perfect. Chalo. Next question guys. The value of 2 times 1p0 minus 3 times 2p1 plus 4 times 3p2 alternatively plus 1 factorial minus 2 factorial plus 3 factorial minus so on up to 50 first term. Let's do this question. 1p0, 2p1, 3p2 we can calculate. This is nothing but, see, this is nothing but 2 factorial only. This is nothing but 3 factorial only. So basically we can write it like this: 2 factorial minus 3 factorial plus 4 factorial minus 5 factorial plus so on up to 50 first term. 50 first term means 52 factorial, we'll get it. Correct or not? Plus 52 factorial plus next term is what guys? 1 factorial minus 2 factorial plus 3 factorial minus so on up to 50 first term. That means plus 51 factorial. This is what we're getting it. Clear or not? So now let's write all the positive terms at one place, all the negative terms at one place and calculate this. Let's see what we get it. Write down all the positive terms at one place. If you write down all the positive terms at one place, 1 factorial otherwise we can simplify these two terms at one place guys. These two terms at one time you simplify this, these two terms at one time you simplify this. Hello Krishna Sharma. So 2 factorial minus 3 factorial. See, n factorial minus n plus 1 factorial, we can write it like this. You can take n factorial common, 1 minus n plus 1, which is equals to minus of n into n factorial. This way we can simplify this. If we simplify this, can we write this entire thing as minus 2 into 2 factorial? This also, this we can write it as minus 4 into 4 factorial. Next, minus 6 into 6 factorial plus so on up to how many terms guys? Total so on up to how many terms? So total up to 51 till 51. So we can write it as minus 50 into 50 factorial plus 52 factorial. That's what we can write it. First term. Next, remaining these two also we can simplify this. These two also we can simplify it like, otherwise actually you can cancel it guys. You can cancel it all this. Instead of writing all this, you can cancel it. Few terms are getting cancelled here. See here. What are the few terms are getting cancelled? 2 factorial cancelled. 3 factorial cancelled. All these are getting cancelled. Till 50 first factorial we can cancel. So finally we are getting 1 factorial plus 52 factorial only we are getting it. Clear now? So then it will be 52 factorial plus 1 we get it. That's it. Second option we're getting it. So directly plus 2 factorial minus 2 factorial is getting cancelled, guys. This is better method. Instead of writing this one, better if we can cancel it. Clear? This we don't need actually. So guys, everyone understood? Clear now? Perfect. Chalo guys, let's move to the next one. Next question. Total number of 3-digit numbers whose sum of the digits is 10, he is saying. Sum of the digits should be 10, guys. So sum of the digits means you can take a 3-digit number as ABC such that A plus B plus C is equals to 10. So guys, start doing this question and tell me the answer for this. This is an integer type question. Total number of 3-digit numbers whose sum of the digits is 10. So A value should not be 0. So A value should be greater than 0. Whereas B and C should be greater than or equals to 0. Okay. If you take A is equals to 1, suppose A value we can't take 0. A value we can take 1 or 2 we can take, 3 we can take. If you take A is equals to 1, we are getting B plus C is equals to 9, guys. So how many solutions for this? How many solutions for B plus C is equals to 9, guys? B plus C is equals to 9. How many solutions are there? So there is a formula for this, guys. x1 plus x2 plus x3 plus so on up to xr is equals to n. Number of non-negative positive non-negative integral solutions formula is n minus 1 cr minus 1. This is the formula. Number of non-negative positive solutions. So in place of r, if I take 2, let's say in place of r, if I take 2, how much I get it? Number of solutions for x1 plus x2 is equals to n is n minus 1 c1. So that means n minus 1 solutions we are getting it. So that means for this we get total 8 solutions, guys. Total 8 solutions we get it. So like 1, 8, 2, 7, so on up to 8, 1. So total 8 solutions we are getting it. So same way, if I take A is equals to 2, how many solutions I'll get it? 7 solutions I'll get it. If I take A is equals to 3, how many solutions I'll get it, guys? 6 solutions I'll get it. So on, if I take A is equals to 8, suppose B plus C is equals to 2, in that how many solutions I'll get it? Only 1 solutions I'll get it. Correct or not? But actually here we are calculating only positive integral solutions. Positive integral solutions we are taking or non-negative integral solutions we are taking. Why? Because B and C can be 0 also. B and C can be 0 means we can take 0, 9, 9, 0 also we can take it. If we take it like this, how many we are getting, guys? We are getting total 10 we are getting here. Correct or not? One second. Let me erase this here. So let's check it again. If I take B plus C is equals to 9, so total 0 to 0, 9, 1, 8, 2, 7, so on up to 9, 0. Total 10 solutions we are getting here. So here 9 solutions, here 8 solutions, so on up to here how many solutions? 3 solutions. If you take A is equals to 9, B plus C is equals to 1. In this case, how many solutions we are getting, guys? In this case also we are getting 2 solutions like 1, 0, 0, 1. Clear now? Everyone understood this? Clear? So this is a number of positive integral solution. What is the number of non-negative integral solution formula, guys? N plus r minus 1 cr minus 1. If you substitute r is equals to 2 here, what we get it, guys? N plus 2 minus 1 c2 minus 1, which is equals to n plus 1 c1, which is equals to n plus 1. That's how we are getting n plus 1. Here n is equals to 9, we are getting 10 solutions. If n is equals to 8, 9 solutions like this. Clear? So that means if you take A is equals to 1, we are getting total 10 solutions. If you take A is equals to 2, 9 solutions. Like this, final answer is going to be 2 plus 3 plus 4 plus so on up to 10 only. So what is this value, guys? Isn't it 54? Isn't it 54 or not? Why? Because sum of first 10 natural numbers we know it. 1 plus 2 plus 3 plus so on up to 10 we know it, which is 55 only. N into n plus 1 by 2, 55. So here minus 1 we need to do it because 1 is not there. So 54 solutions we are getting it. Clear now? We just need to add all this. Okay, everyone understood? Chalo, let me discuss one more time. So we need to calculate a 3-digit number ABC. We need to calculate number of 3-digit numbers ABC such that sum of the digits should be equals to 10. That means A plus B plus C should be equals to 10. Where A value should not be equals to 0, because if you take A is equals to 0, we don't call it as a 3-digit number. So compulsory A value should be not equals to 0. So A value, the possible values of A is 1, 2, 3, 4, so on up to 9. So if I take A is equals to 1, B plus C is becoming 9. If I take B plus C 9, total how many solutions we are getting it? 0, 9, 1, 8, 2, 7, so on up to 9, 0. So total 10 solutions we are getting it. Otherwise, we can use this formula. Number of non-negative, positive, non-negative integral solutions for the equation x1 plus x2 plus x3 so on xr is equals to n is n plus r minus 1 cr minus 1. If we use this formula, in place of r we need to substitute 2 guys. Why? Because here only 2 variables are there. One variable is b, one variable is c. If you substitute n is equals to 2 here, n plus 2 minus 1, c2 minus 1, which is n plus 1. That means if you take n is equals to 9, we get 10 solutions. If you take n is equals to 8, 8 plus 1, 9 solutions, like that. So for b plus c is 8, 9 solutions. B plus c 7, 8 solutions. So on up to b plus c2, 3 solutions. B plus c is equals to 1, 2 solutions. What are the 2 solutions? 1, 0, 0, 1. 1, 0, 0, 1. Clear? Hello, Bishwajit Kumar. So we added all these solutions, number of solutions, and we are getting 54. Okay, right. So that's the answer, guys, 54. Clear? Perfect. Yes, exactly. We can done this by using this method also, guys. Let's try this method. If we use this method, A plus B plus C is equals to 10. But where A is greater than or equals to 1, B is greater than or equals to 0, C is greater than or equals to 0. So what we can do is, we can write A minus 1 greater than or equals to 0 here, and this A minus 1 we can take it something like x. Now can I write in place of A, can I substitute x plus 1, guys? Can I write it like this? If I take A minus 1 greater than or equals to 0, in place of A, can I take x plus 1? Let's take x plus 1 plus B plus C is equals to 10. So from this we are getting x plus B plus C is equals to 9. So now you can calculate number of non-negative integral solution. The formula is n plus r minus 1 cr minus 1, where n is equals to 9 here and r is equals to 3 here. Let's substitute these values here. If you substitute these values here, what we get it? 9 plus 3 minus 1 c 3 minus 1, which is equals to 11c2. 11c2 means what, guys? 11 into 10 by 2, which is 55. But why we are getting one solution extra? Because we are calculating 1000 also one solution. 1000 also one solution we are calculating. That particular solution we need to remove. So that's why solution is going to be 55 minus 1. Clear na? So 54 is the answer. Clear? Pardeep, every class PDF I am uploading after the class, guys. So you can collect the PDF after the class. Otherwise, you can join my Telegram group. This is my Telegram group. You can search my name in Telegram. You will find my Telegram group. So in that, you will get all the PDFs of this 3000 practice problem series. Clear now? Right, chalo. So this is the next question we have. The value of sigma r is equals to 0 to 20, 50 minus r, C6. Substitute all these values. R is equals to 0. Total how many terms are there, guys? R is equals to 0 to 20. How many terms are there? 21 terms are there. Substitute R is equals to 0 here. If you substitute R is equals to 0 here, 50C6 plus 49C6 plus 48C6 plus so on up to. If you substitute R is equals to 18, how much we getting it? R is equals to 18 if you substitute it. 32C6 plus if you substitute R is equals to 19. How much we getting it? 31C6 plus 30C6. That's what we're getting it. So what we'll do is, to simplify this, we'll add one term and subtract one term. So which term we can add it and subtract it? Can we add 30C7? Can we add it, guys? I'm adding 30C7 and subtracting 30C7. Now tell me, what is sum of these two values, guys? Sum of these two values is how much? Can I write it as 31C7? Can I write it as 31C7? Why? Because we have this formula. We have this formula. NCR plus NCR plus 1 is equals to N plus 1 CR plus 1. We have this formula, guys. If we use this formula, we can able to write 30C6 plus 30C7 as 31C7. Clear now? Everyone understood this? Right. Same way, we can simplify these two. How can we simplify these two? Can we write it as 32C7? Can we write it like this? Correct now? Right. Same way, these two, can we simplify this? These two, can we write it as a 33C7? Finally, how can we write it? If you keep on adding like this, finally, what is the final answer, guys? Final answer, we are getting like 51C7. That's what we're getting it. Clear? Understood or not? So tell me, guys, what is the answer? Finally, we are getting only two results. Two values we are getting it. What are these two values? One is this and another one is this. So if you club these two, 51C7 minus 30C7. That's what we're getting it. First option we're getting it. Clear or not? Everyone understood or any doubts? So this formula is important, guys. NCR plus 1 is equals to N plus 1 CR plus 1. Okay. This is the important formula. Otherwise, you can write it like this also. You can write it like NCR plus NCR minus 1 is equals to N plus 1 CR. Both the formulas are same only, guys. Both the formulas are same. Clear? Perfect. So first option is the answer. Right. Next question, guys. Right. Let's do this question. A test consists of 6 multiple choice questions, each having 4 alternative answers, of which only one is correct. The number of ways in which a candidate answers all the 6 questions correctly. All the 6 questions, that exactly 4 answers correct. So out of 6 questions, 4 questions correct and 2 questions wrong, guys. Out of 6 questions, 4 questions correct and remaining 2 questions incorrect. Clear? So what we'll do is, 2 questions we need to select it. 2 questions we need to select to make it incorrect. So how many ways we can select 2 questions, guys? 2 questions we selected. And how many ways we can make it incorrect? See, there is only one possible answer, one possible correct answer. How many possible incorrect answers? 3 possible incorrect answers. So, once I selected 2 questions, let's assume out of A, B, C, D, let's say A, B, C, D, E, F, total 6 questions are there. Out of 6 questions, I selected these 2 questions, let's say. This question and this question I selected. These 2 questions, how many ways we can make it incorrect? 3 ways only, right? Each and every question can be make it incorrect 3 ways. Correct. And remaining how many questions are there? Remaining 4 correct questions are there. These 4 questions we need to make it correctly. How many ways? 1 way only. This is 1 way. This is 1 way. This is 1 way. This is 1 way. Whereas this incorrect questions we can make it incorrect by 3 ways. So we selected 2 questions and these 2 questions we can make it incorrect by 3 ways, and 6C2 into 3 into, and we can make it correct questions by only 1 way. So 6C2 into 3 into 1. Clear na? So 6C2 is how much, guys? 6 into 5 by 2 into 3. So how much we getting it? 6. So 3 into 5, 15 we are getting it. And actually here 2 questions we need to make it incorrect, guys. 2 questions we need to make it incorrect. So 15 times 9, which is equals to 135. Clear now? Everyone understood this? So we need to select 2 questions. We need to select 2 questions out of 6 questions. Okay, we selected 6C2. And once we selected 2 questions, those 2 questions we can make it incorrect by 3 into 3 ways. One question 3 ways, another question 3 ways. And what about this? We can make it remaining 4 questions correct in only 1 way. So 1 into 1 into 1 into 1. So which is 1 power 4. That's what we're getting. Correct. Binomial distribution also you can do it. Yes. Saira's correct. Clear now? So this is the answer. Final answer is 135. So clear. Right. Perfect, guys. So 135 is the answer. Chalo, let's move to the next question. So this is the next question. Number of words with or without meaning that can be formed by taking 4 letters at a time. Only 4 letters we need to take, guys. Out of this 8 letters, we need to take only 4 letters such that 2 letters are distinct and 2 letters are alike. Okay, let's write all the similar letters at one place. So yes and yes, they are alike. So we'll keep it at one place. And L and L, these 2 letters are alike. So we'll keep these 2 letters at one place. And remaining all the letters are different. So we can take it like this. Y, A, B, U. So guys, clear? So we need to select 2 distinct letters and 2 letters are same. So let's select 2 letters first. 2 alike letters, we'll take it first. 2 alike letters, how many ways we can select it, guys? 2 alike letters, how many ways we can select? Only 2 sets of 2 alike letters are there. So from this 2 set, we need to select 1 set. Okay, let's select 1 set in 2C1 ways. Okay, in 2C1 ways, we selected. Let's assume that we selected yes and yes. Now, 2 more letters which are distinct letters we need to select. How can we select distinct letters? Either we can select L also. Why? Because we selected only yes and S. So remaining out of these 2 L's, we can select L also. So 1, 2, 3, 4, 5. Out of this 5, we need to select 1 letter. 2 letters, sorry. Out of this 5 letters, we need to select 2 letters. L and L, we consider it as only 1 letter, guys. Why? Because we can't select both the letters of L. We can select only one L. So that's why either we can select L, Y, A, B, U. Out of these 5 letters, we can select only 2 letters. So once we selected 2 letters, let's assume that I selected one L and one B I selected. Now how many ways we can arrange these 4 letters, guys? How many ways we can arrange these 4 letters? These 4 letters can be arranged in 4 factorial by 2 factorial. Why? Because one S is repeating. One letter is repeating, so that's why 4 factorial by 2 factorial. So now write down this 4 factorial by 2 factorial. Let's simplify this. So clearly we can cancel this 2 and 2. If you cancel this 2 and 2, how much we getting it? So 5C2 is how much, guys? 5 into 4 by 2 into 4 factorial is how much? 24. So total how much we getting it? 10 into 24 we are getting it, which is equals to 240. So guys, is it correct? Is it correct, guys? Six C2 we get it, or 5C2 we get it, guys? Cyrus, 6C2 will get it or 5C2 will get it? Correct. 5C2 will get it, guys. Everyone understood this? Hi, Arbus. Right. So clearly we can say that. Let me explain this question again. Total 8 letters are there. Out of these 8 letters, these two S's are alike, these two L's are alike, and remaining 4 letters are distinct. So we need to select a 4-letter word with the 2 letters are same and 2 letters are distinct. 2 letters are alike and 2 letters are distinct. So how many ways we can select 2 letters of same? See, 2 sets of 2 alike letters are there. Either we can select SS or either you can select LL. So there is 2 possible ways. Once you select SS, let's assume that I selected SS or LL, anything is fine. Once if I select LL, SS, remaining how many letters we can select? Out of 5 letters, we can select 2 letters. We can consider LL as only 1 letter. If you consider LL as only 1 letter, total 5 letters, we need to select 2 letters. Okay, once we selected 4 letters, out of this 2 letters are alike, we can rearrange these 4 letters in 4 factorial by 2 factorial. Because of this, 2 letters are repeating by 2 factorial. Now when we multiply all this, we are getting 240. So 240 is the answer. Clear now? 2C1 into 5C2 into 4 factorial by 2 factorial. Perfect. Understood? Right. Chalo, let's move to the next question. L repeated है तो 2 factorial से divide नहीं करेगा. Ankit, see, because L is repeating here, suppose let's say, instead of taking SS, suppose if I take LL I took it, and let's say AB I took it. Here also same thing, 4 factorial by 2 factorial only. Why? Because L is repeating, na? L is repeating, right? When repetition is there, we need to divide with 2 factorial, right? Let's say APP apple is there, let's say suppose APP apple, APPLE apple. So how many words we can form with this? 5 factorial by 2 factorial only, right? Why? Because 2 P's look like alike. These P and P look alike. So we are over counting it. So to reduce that by 2 factorial, we are doing it. Clear now? Number of words formed with the letters of the word apple can be rearranged. Clear? Right. Chalo, let's move to the next one. Yeah, this is the next question we have. There are 3 sections in a question paper. Each section contains 5 questions. A candidate has to answer a total 5 questions, choosing at least 1 question from each section. See guys, section A, B, C contains 5 questions each. Clear? And we need to select at least 1 question and total should be 5 questions. Clear now? Right. So total we need to select 5 questions so that at least 1 question from each section and the number of ways in which candidate can choose a question paper. So guys, start doing this question. Start doing this question. So A, B, C, A is consisting of 5 questions, B is consisting of 5 questions, C is consisting of 5 questions. So we need to select 5 questions so that at least 1 question from each set. So here one question we can select, or here 1 question we can select, or here 3 questions we can select. Clear? So that means out of 5 questions, 1 question we need to select. Out of 5 questions, 1 question we need to select. Out of 5 questions, 3 questions we need to select. Clear? Like that, how many are there? Like this, 3, 1, 1 is there. 1, 3, 1 is also there. So can I multiply this into 3 times? Instead of counting one more time, can I write it into 3? Can I write it like this? Correct now? Next, what is the next possibility, guys? What is the other possibility we can have? Other possibility we can have is 1, 2, 2. Correct now? So 1, 2, 2 means what? 1, 2, 2 means from 5 questions we need to select 1 questions. From 5 questions we need to select 2 questions. From 5 questions we need to select 2 questions. And like this, how many are there? 2, 1, 2 is there. 2, 2, 1 is also there. So again 3 possibilities. So can I multiply with 3? Correct now? So these are the possible cases only we are getting it right. So these are the possible cases we are getting it. So we just need to add these cases. Let's add these cases. If you add all these cases, how much we are getting it? Add all these cases. So 5C1 into 5C1 into 5C3. 5C3 is how much, guys? 5C3 is equals to same as 5C2, which is equals to 5 into 4 by 2, which is equals to 10. So this is 5 into 5 into 10, which is equals to 250. 250 into 3, which is 750. Plus second one also, guys. Second one also, what we get it? Second one, 5 into 10 into 10, 500 into 3. 500 into 3 is what, guys? So this is 1500 actually. This is 1500. And what about this, guys? This is 5 into 5 into 10, 500. 3 500. So 1 second, guys. This is 5 into 10 into 10, 500. This is 5 into 5 into 10. So which is 250, guys. 250 into 3, 750. So we need to add these two. So if you add these two, how much we getting, guys? 2250, are we getting it? Yes, perfect. We're getting 2250. Everyone understood these cases? Chalo, let me discuss one more time. There are 3 sections are there. Each section contains 5 questions, and we need to select total 5 questions so that each section should get at least 1 question. So these are the possibilities: 113, 311, 131, 122, 212, 221. 113 case we calculated 5C1 into 5C1 into 5C3. Same we'll get it 3 times. So into 3. Same way 122 also 5C1 into 5C2 into 5C2 into 3, because 3 cases are there. Now we added all these cases and we are getting 2250. Clear now? Understood? Perfect. Chalo guys, let's move to the next question. Yeah, this is the next question we have. 2 families with 3 members, 2 families with 3 members each, and 1 family with 4 members are to be seated in a row. In how many ways can they seat it so that the same family members are not separated? So that means same family members should be together. 2 families with 4 members and 1 family with. So that means you can take it like this: 1 family with 3 members, 1 family with 3 members, and 1 more family with 4 members. Total these 10 members we need to arrange it. Hello Ansh. So tell me guys, what is the answer for this? So we need to club it as a one group. These 3 members we need to club it as one group. Let's club these 3 members as one group, and these 3 members as one group, and these 4 members as one group. Clear? So if we club this 3 members as a one group, how many groups are there, guys? How many groups are there? 3 groups are there. How many ways we can arrange these 3 groups? Isn't it 3 factorial? Yes, 3 factorial ways we can arrange these 3 groups. But within this group, we can arrange these 3 people, right? How many ways we can arrange these 3 people? 3 factorial ways. Let's write it this way: 3 factorial ways we can arrange these 3 people. And the second group, this green color group also, we can arrange it in 3 factorial ways. And this blue color group also, we can rearrange it in 4 factorial ways. That's what we're getting or not? Correct na? Now tell me how much we get it. Is it 3 factorial whole cube into 4 factorial or not? Are we getting first option or not, guys? What we have done here? These 3 people should be together, and these 3 people should be together, and these 4 people should be together. So what we have done? These 3 people we bundled. We put it as one group. And these 3 people we put it as a one bundle, and these are in one group. These 4 are in one group. So 3 bundles are there. These 3 bundles we can arrange it in 3 factorial ways. And this 3 members in that bundle we can rearrange it in 3 factorial, and these 3 members in that bundle we can rearrange it in 3 factorial ways. These 4 members we can rearrange it in 4 factorial ways. So finally this is what we're getting it. So first option is the answer. Clear? So guys, is it clear? Perfect. Perfect. Chalo guys, let's move to the next one. Right, first option is the answer. Number of words that can be formed from all the letters of the word letter in which vowels never come together. Vowels should never come together, guys. So tell me the answer for this question. Everyone, what is the answer for this question? How many vowels are there here? How many vowels are there? Only 2 vowels are there, correct or not? A, E, I, O, U, right? So only 2 vowels are there, E and E. These 2 vowels should not be together. So what we'll do? First we'll arrange the consonants. What are the consonants we have? How many consonants we have? 4 consonants we have. L, T, T and R. 4 consonants we have. So we'll arrange these 4 consonants in 4 places, guys. How many ways we can arrange these 4 letters in 4 places? How many ways we can arrange it? How many ways we can arrange these 4 letters? Isn't it 4 factorial by 2 factorial? Correct or not? Isn't it 4 factorial by 2 factorial, guys? Correct. So maybe L is here, R is here, T is here, T is here. Okay. 4 factorial by 2 factorial ways we arranged. And now these 2 E's we need to arrange. We need to arrange in these places. This is one place, second, third, fourth, fifth. So total 5 places are there. In these 5 places, you didn't understand, Shubham? Okay, we'll discuss again, don't worry. In these 5 places, we need to put these 2 letters. Only selection, guys. Only we need to select any 2 positions here. Why not arrangement? Because E and E are similar. E and E are similar. Because they are same. Whether you substitute one E here. Okay, let's take it like this. One E here and one E here. Or maybe one E here, one E here. Both are same. So there is no arrangement. Only selection. We just need to select any 2 places out of this 5 places. Out of this 5 yellow color places, we just need to select only 2 places. How many ways we can select that? Isn't it 5C2? We selected 2 places. In that 2 places, how many ways we can put this E and E? Only one way. Let's assume I selected this and I selected this. How many ways I can put this E is here? Only one way. Correct. So 5C2 into 4 factorial by 2 factorial. That's it. That is the answer. Let's simplify this. How much we get it? 5 into 4 by 2 into 4 factorial by 2 factorial. 4 factorial is 24 by 2. So tell me how much we're getting it. Are we getting 120? Clear na? So 120 is the answer. Guys, now tell me, any doubts in this? Anyone has any doubt? Subham, you understood or should I repeat it again? Anyone want me to repeat this question, guys? Everyone understood or should I repeat it? See, total 6 letters are there. Out of 6 letters, 2 vowels and 4 consonants are there. So what he is saying, these 2 vowels should not be together. First we arranged 4 consonants, 4 factorial by 2 factorial ways. Clear? And then in between these 4 letters, we have 5 places are there. In these 5 places, we need to arrange these 2 letters. So we selected 2 places. Out of these 5 places, we selected 2 places. 5C 2 ways. Once we select 2 places, in these 2 letters, in these 2 places, how many ways we can arrange it? Only one way, because E and E is repeating. Clear na? Ankit, here E and E, similar objects. That's why into 2 factorial is not there. Only selection, there is no arrangement. Why? Because similar objects, right? Whether you substitute one E here, one E here, even if you interchange both the E's, it look like same only. Correct or not? Perfect. Right. Let's do one more question, guys. This is the last question we have. That's it. Only 10 questions we have. So we finished it, guys. See, total 10 questions in 2020 September, guys. We finished all these 10 questions. Total minus vowel together. Yeah, Cyrus, that method is also fine. Total minus vowels together. That is also we can do it. Let's do that method. Total minus vowels together case we can do it, guys. Total how many words are there? Total number of words are 6 factorial by 2 factorial into 2 factorial. These are total, which is 720 by 4, which is equals to how much, guys? 180, right? 180. So total 180 words we are getting it. Out of this 180, where these 2 E's are together, 2 E's are together means what? These 2 E's we should club it together. And how many letters are there, guys? Remaining how many letters are there? L is there, T is there, T is there, and R is there. Correct? So now how many ways we can rearrange it? Isn't it 5 factorial by 2 factorial? Isn't it 120 by 2, which is 60? So that means out of 180 words, 60 words where both the E's are together. So what we can do is we can subtract these 60 from total number of words. That is 180 minus 60, which is equals to 120. This method is also fine. Okay, right. So Pardev, for every chapter we are discussing mains previous year questions, advanced previous year questions. First we'll discuss mains previous year questions, and then advanced previous year questions we'll discuss, and then few important models also we'll discuss for every chapter. Clear na? So guys, every chapter first we'll discuss mains questions, and then advanced questions, and then few important models also we'll discuss. Clear na? Right. Perfect, guys. First we'll discuss mains level questions. We completed 2020 mains September questions, and in the next class we'll discuss January questions, and 2019 questions we'll discuss. Okay, right. So guys, everyone like this session, and see you in the next class, guys. So next class we'll have every Monday, Wednesday, Friday night 9:30 p.m. we'll have this 3000 practice problem session, guys. Okay. Ankit, I am from IIT Roorkee. Okay. Right. Yes, Vivek, I am taking plus courses. I am taking for both 11th and 12th plus courses. So if you want to join plus courses, you can use this referral code Praneet10 and join the plus platform, guys. Okay, right. So guys, good night everyone. Take care everyone, and happy Diwali. Take care of yourself, guys, and see you in the next class. Okay, so bye, guys. Take care everyone. Good night. Shakir, good night. Thank you, Ankit. Thank you. No, Vivek, we'll discuss mains as well as advanced also. Okay? Yeah. Thank you, Ankit, Arpan. Thank you, guys. See you in the next session. Good night.